In the last century alone, we've made incredible progress. We've detected gravitational waves, captured the first image of a black hole, and discovered thousands of exoplanets that might host life. But the more we learn about the universe, the more we realize just how many mysteries remain unsolved. From vast, empty regions of space to a strange visitor to our solar system, scientists are constantly uncovering phenomena that challenge what we think we know about the universe. In this video, we'll explore 8 of the most intriguing space mysteries. Let's start with a concept that almost sounds like something out of science fiction: supervoids. These are gigantic regions of space where there seem to be far fewer galaxies, stars, and matter than we'd expect. In some cases, these voids can stretch for hundreds of millions of light years, becoming mind-bogglingly large empty zones. One of the best examples is the Eridanus supervoid, which some scientists connect to the cold spot in the cosmic microwave background, or CMB, the leftover radiation from the Big Bang. Astronomers found a region in the CMB that's cooler than average, and a possible explanation is that there might be a huge void in that area. Photons traveling through it would lose a bit of energy, showing up as a cooler patch. Other scientists suggest it might be just a statistical fluke or something even stranger we don't fully understand yet, but the supervoid idea remains one of the leading possibilities. In general, our understanding of the universe says matter should clump together into galaxies and clusters thanks to gravity. And indeed, we do see vast filaments and clusters across the cosmos. We also expect some empty pockets here and there, but supervoids can be bigger and emptier than theories predict. It's possible that we're seeing a natural but rare occurrence, or that our models of how dark matter and ordinary matter cluster together need adjusting. If supervoids don't fit well into our current understanding, it could mean we've overlooked something fundamental about how the early universe evolved. Explanations vary widely. On one hand, it might just be luck. Given enough space and time, it's not shocking to find huge gaps now and then. Another angle is that there were early universe fluctuations that left these regions sparse in matter. Some astronomers also wonder if the distribution of dark matter or dark energy, more on them in a bit, might behave differently in these areas, creating extra giant voids. Ongoing galaxy surveys are helping us map out the large-scale structure of the cosmos more accurately than ever. As these surveys expand, they could confirm or challenge our ideas about how such gigantic voids form. Now let's zoom in on a much smaller but equally mysterious visitor that whirled through our solar system not long ago. In October 2017, astronomers in Hawaii spotted a faint, fast-moving object using the Pan-STARRS 1 telescope. At first, they assumed it was just another asteroid or comet, but soon they realized this object had come from outside our solar system, becoming the first known interstellar visitor. They named it Oumuamua, Hawaiian for a messenger from afar arriving first, because it quite literally came from far, far away. What really grabbed everyone's attention was its unexpected motion. It behaved almost like a comet speeding away from the sun, but astronomers couldn't detect any gas or dust streaming off of it. So, if it wasn't a normal comet, and it wasn't behaving like a typical asteroid, what was it? Observations suggested that Oumuamua might have an elongated shape. Some called it cigar-like, though newer models suggest it could be flatter, more like a pancake. Either way, it's nothing like the roundish rocks we're used to seeing. It also spun in a strange way, reflecting sunlight in irregular patterns. Then there's the mysterious acceleration. It seemed to speed up, but without the usual comet tail to explain why. This odd combination of factors left scientists scratching their heads. Plenty of ideas were thrown around. Maybe it was a weird comet that still released gas, but not in a way our instruments could pick up. Some suggest it could be a shard from a planet or asteroid that was shattered in another solar system, eventually finding its way here. Another out there idea is that it was mostly made of frozen hydrogen, which could evaporate without leaving obvious signs. And one controversial theory proposed it might be a solar sail or some sort of artificial craft. Most scientists doubt this, but it certainly caught the public's imagination. Oumuamua was the first time we could observe an interstellar object up close, relatively speaking, so it opened up questions about how common these roaming bodies are. Even though the majority leaned toward a natural explanation, the short window of observation left a lot of room for guesswork. Once it moved away from the sun, it faded quickly, making follow-up measurements almost impossible. Now let's turn to the possibility of a hidden planet right here in our solar system, one that could be hiding far beyond Neptune. The idea of a Planet X has been around for over a century. Back in the early 1900s, astronomers thought irregularities in Uranus and Neptune's orbits might be caused by another planet yet to be discovered. This search led to the discovery of Pluto in 1930, but it turned out that Pluto was too small to account for the orbital weirdness. Over the years, various theories popped up suggesting another planet might be out there, only for most of them to fall apart under closer inspection. But the Planet X hypothesis never really died. It just sat on the back burner. Then, in recent times, the idea resurfaced in a big way, thanks to fresh data from the far reaches of the Kuiper Belt. Around 2016, two astronomers, Konstantin Batygin and Michael E. Brown, noticed that a handful of objects in the Kuiper Belt clustered in suspicious ways. These trans-Neptunian objects, or TNOs, had orbits that seemed to point to a massive planet, maybe 5 to 10 times Earth's mass, on a highly eccentric path far beyond Neptune. They published a paper suggesting this so-called Planet 9, some still call it Planet X out of loyalty to Pluto, could be shepherding these distant objects. The proponents of this theory say the clustering of these TNOs seems like more than a coincidence, and simulations show that a big planet could be the cause. But critics say the sample size is small, and observational bias could trick us into seeing patterns that aren't really there. Plus, we haven't seen the planet itself, even with powerful telescopes scanning the sky. If Planet X is real, it's likely so far away that it's incredibly faint. Its orbit might take thousands of years to circle the sun just once, meaning it moves very slowly against the background stars. Existing surveys can miss such a faint, slow-moving object, especially if it's in a part of the sky that's tough to observe. That's why the search can feel like looking for a needle in a haystack. If we do find Planet X, that might mean we have to rethink how the solar system formed, possibly incorporating theories about planets being flung outward by gravitational interactions in their early days. Or maybe Planet X is actually a captured rogue planet. More on rogue planets in a bit. Either way, its discovery or definitive absence will be a big moment for planetary science. So far, we've explored everything from an interstellar visitor to a potential hidden planet. Now, let's discuss something that seems almost intangible: dark matter, the invisible glue that appears to hold galaxies together. The story of dark matter began in the 1930s with Swiss astronomer Fritz Zwicky, who studied how galaxies in the Coma cluster were moving. They zipped around so fast that they should have flown apart, unless there was some extra unseen mass keeping them bound. Later, in the 1970s, Vera Rubin measured how fast stars orbit in spiral galaxies and found that stars on the outskirts were moving nearly as fast as those near the center, something that shouldn't happen if only visible matter were present. These findings hinted at a huge amount of missing mass, which we now call dark matter. So, what could dark matter be? Scientists have come up with a few main ideas. First up, we have WIMPs, or weakly interacting massive particles. These are potentially heavy particles that interact with normal matter so weakly they're nearly impossible to detect, aside from their gravitational effects. Then there are axions. These are incredibly light particles that might exist according to certain theoretical physics models. Scientists are still trying to figure out if they're real and could help explain dark matter. Lastly, we have MACHOs, or massive compact halo objects. These include things like brown dwarfs or black holes. While they might sound like a good candidate, surveys suggest they can't make up the majority of dark matter. It's one thing to say, there must be something out there, and another to pinpoint what that something is. The leading theories haven't been conclusively proven, and some scientists propose alternative explanations, like modified Newtonian dynamics, or MOND, which tweaks gravity itself. While MOND can help explain some galaxy rotation curves, it struggles on larger scales like galaxy clusters. So, for now, the mainstream idea is still that dark matter exists as a new kind of particle or set of particles, and we just haven't managed to catch it yet. But while dark matter is holding galaxies together, there's another, even more mysterious force, one that doesn't pull, but rather pushes the universe outward. In the late 1990s, astronomers studying Type 1a supernovae discovered something mind-blowing. Instead of slowing down, the expansion of the universe is speeding up. This was totally unexpected. A nod to this idea had existed before. Albert Einstein called it the cosmological constant when he first tried to model a static universe. He later called it his biggest blunder, but modern observations suggest he might have been onto something. We now refer to whatever's causing this acceleration as dark energy. Even though dark energy makes up about 68 to 70% of the total energy content of the universe, we barely know what it is. One idea is that it's a constant property of empty space, often called vacuum energy. Another is that it's some kind of dynamic field, like quintessence, that changes over time. Some physicists even wonder if our understanding of gravity is incomplete, and that we don't need dark energy at all if we fix our equations. The truth is, we don't have a definitive answer yet. Cosmic microwave background data show that the geometry of the universe, plus the overall energy content, points to a big chunk of energy we can't see. Additionally, surveys of galaxies over vast distances match models that include dark energy. Different methods of measuring the expansion rate produce slightly different results, suggesting that there might be more to discover or some twist in how dark energy behaves. Ultimately, understanding dark energy could tell us how the universe will end. Will it expand forever, slow down, or tear itself apart in a big rip? One thing's for sure, dark energy is a huge mystery waiting to be solved. For decades, scientists involved in the search for extraterrestrial intelligence, or SETI, have used radio telescopes to scan the skies for signals that might be from alien civilizations. Most of the time, we only pick up static or signals we can explain. But in 1977, something happened that made everyone take notice. On August 15th, the Big Ear radio telescope at Ohio State University recorded a 72-second spike in intensity around the 1420 MHz frequency, which is a key frequency for hydrogen. Astronomer Jerry Amon was so surprised by the data that he wrote "wow" in the margin, giving the signal its name. It was very sharply tuned, which is uncommon for natural cosmic sources, and it clearly rose above background noise. Nobody has ever detected it again, despite many follow-up attempts. Its mysterious nature caused many to wonder if it might have been a deliberate signal from an alien civilization, or just an odd one-off natural phenomenon. Even now, the WOW signal is a legend in SETI. Modern surveys like the Breakthrough Listen program are more sensitive and cover more frequencies, so if a similar signal appears, we'll be better equipped to study it. Until then, the WOW signal remains one of astronomy's most enticing what-ifs. This brings us to a broader question about alien life. If the universe is so big and so old, why haven't we definitively found anyone else out there? In 1950, physicist Enrico Fermi famously asked, "Where is everybody?" Given the staggering number of stars and the likelihood of habitable planets, it seems probable that intelligent life should have arisen somewhere else by now. And if it did, shouldn't there be obvious signs, like probes, transmissions, or something else? With billions of stars, life could start many times, and eventually, some forms of life gain technology. After that, civilizations might spread, or at least try to communicate. Therefore, such advanced life should leave evidence we can spot. Yet, we don't have conclusive proof of any large-scale alien presence, which leads to all sorts of theories. Perhaps it's incredibly tough for life to progress to intelligence. Civilizations might self-destruct or fail to reach a point where they can explore the galaxy. Maybe advanced aliens purposely leave us alone, or we're too primitive to notice. Our current detection methods might be too narrow. aliens could be using technology we haven't even imagined. And some suggest alien life could be hidden among us, though there's no solid evidence for this. The Fermi paradox isn't just academic, it makes us think about our own future. If there's a great filter, some catastrophic step civilizations rarely get past, could we be approaching it now, or have we already beaten the odds by existing at all? Thinking about these questions can guide how we approach sustainability, technology, and the long-term survival of our species. Programs like SETI, Breakthrough Listen, and advanced exoplanet searches keep looking for signs of life or intelligent signals. We're also studying the atmospheres of exoplanets for biosignatures like oxygen or methane. Each new observation increases our odds of finding aliens or reveals the silent vastness of space. Next, let's look at a type of planet that challenges our assumptions about what planets even are. A rogue planet is a planet-like object that doesn't orbit a star. Instead, it drifts through interstellar space, barely emitting or reflecting light. Because they're so dark and cold, they're tough to spot. The most common ways we detect them are gravitational microlensing, when a rogue planet passes in front of a distant star and bends its light, or careful infrared observations for faint heat signatures. Some studies suggest there could be billions of rogue planets in our galaxy alone, possibly more than stars. They might form alongside normal planets, and then get flung out by gravitational interactions. Or they might form in isolation, like a star that never gained enough mass to ignite fusion. It may sound strange, but a rogue planet could support life under certain conditions. If it has enough internal heat from radioactive decay or residual heat from formation, maybe it could maintain a subsurface ocean. A thick atmosphere might also trap some heat. It's a long shot, but it expands our idea of where life might develop. Studying rogue planets gives us valuable insights into planet formation and the evolution of solar systems. If it turns out these unbound planets are common, it means that the early stages of planetary systems might be far more chaotic than we realized. This could shift how we think about how our own solar system formed. We've confirmed only a handful of rogue planets so far, but as our observational technology improves, we'll likely find more. When we do, we'll not only learn about how widespread they are, but also whether they might harbor conditions that allow life. From enormous voids to wandering planets, from hidden signals to the cosmic force accelerating our universe, we've seen how much remains unexplained. Today's space mysteries may look different, but all these riddles share one thing. They remind us how little we actually know about the universe. And solving these mysteries will only lead to new questions because of our endless curiosity. That's what keeps astronomy and cosmology so exciting. We live in an era of powerful telescopes and advanced simulations. Many upcoming projects promise data that could help solve these puzzles, or reveal even stranger ones. In the end, science isn't just about having all the answers, it's also about loving the search. If you found these space mysteries interesting, please like this video, subscribe to my channel, and hit the notification bell for more stories about our universe. Thank you for watching, and see you next time.